Good. I'm glad to hear that. So what we're talking about today are going to be what are called nth roots and rational exponents. We've actually kind of touched a little bit on this earlier on. And what we're talking about here is this is what we call a fourth root of 81. And what that means is what is a number that you multiply together 4 times together to get 81? So it's one of those things where you're working with what are called nth roots. A lot of these that you'll see, if you break this out, this means it's 3 times 3 times 3 times 3. 3 to the 4th is 81. That's what we're looking at. It's called an nth root. That value of an nth root, you can change it up. It could be any value. We call it the nth root of x. It also means this, x to the 1 over n. Not the yeah, I'm thinking of negative stuff here. So, like I think I've shown you this before. Remember when I said the square root of 16? We knew that was 4. Did I ever show you that is 16 to the 1/2 power? Remember when we talked about exponent rules? Remember when we did like 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and so on and so on? And we went backwards. We did 2 to the 0. What is anything to the 0 power? 1. But if you look at it, between 0 and 1 is a half. So that's where you get these nth roots from. It's pretty easy to work with. There's a lot of mumbo jumbo here for something that makes it's really, really easy. When you have nth roots, if the nth root is odd, like a third, so let's say it's the cube root, that means there's just one root. So the cube root of 8, what's the cube root of 8? What's a number that you multiply together 3 times together to get 8? 2. What's the cube root of negative 8? It's negative 2. Okay? That's the idea that when you have a big brain on you. All right. So proud of yourself. Starting off the semester proud. When you look at it in terms of odd value, remember you can take an odd root of a negative number because it works itself daily. Same idea when you go to when it even, and when you know this, square root of 16 could be 4, or it could also be negative 4. All right, you know these rules. It's just how they write it out in terms of the fractional value. We're talking about this thing called an nth root. So, excuse me. Example here is square root of 16 would obviously be, that means that it's the number that's there that you don't see is a 2. That just means it's a half power. So that would be 16 with a half power, which is plus or minus 4. A square root is a half power. A cube root is a third power. A fourth root is a fourth power, and so on and so on. So there's many ways to put these things into your calculator if you want. But quite honestly, more often than not, we're not looking at just straight numbers. We're going to be dealing with variables. Do you guys know where the nth root button is on your calculator? I think it says X root. Is that right? All right, let's just run the tracker and see what happens. What? And stop it in. Wah, wah, wah. It won't be a big time. When you're looking at these things, what was it, math? Math 5 is one of the options that you can do. Actually, you can use Rebecca's because she sits in exactly this chair 12 hours on the chart. You can use hers right now. We got to put it back. It's kind of funny that she sits right there, so it works out well. So when you're working with the calculators, there's a couple things you can do. Like I said, when you're working with the calculators, a couple things you do. That math 5 gets you to the x root, and then you can just throw in the values that way. Or if you wanted it to be fancy schmancy, you can use the caret and just use fractional exponents if you want as well, because it means the same. So if I did 16 to the 0.5, if I wanted to type something quickly, if I know that's a half power, it'll work like that as well. But remember, your calculator won't go plus minus. Math 5, that gives you your x root, and obviously your cursor is just going to blink, tell you where to put something in. If you have to simplify an x root, and you're trying to figure out how to do that by simplifying a radical, remember how we did like the square root of 12, we put in our y equals when we did that? Y equal, or 12 over x squared, and we would look for our factors that way. It works the same way when you're looking at third roots, fourth roots, fifth roots. You just change it from squared, cube, fourth, whatever, and it helps you find your roots. As we go along trying to simplify stuff out, I'll show you how to do that. But quite honestly, you get into it, you're not going to get giant numbers anyway, because it just gets really, really messy, really, really quickly. If n is even 8, what is anything to the 0? Oh, sorry. If the value of a is 0, what's the square root of 0? What's the third root of 0? What's anything to the 0? Or 0 to any power is always going to be 0. And then the last one is if a is negative and n is even, you can't take the square root of a negative number because it's imaginary. And just so you guys know, we're going to say something to make your lives happy. We're going to say, for most of this stuff, we're going to see something that says, assume that all variables are positive, which means imagination land can be left alone right now. Okay. All right. So we're going to bounce back and forth between this very, very simple, what is it, nth root of a. And we're going to use that as our basis of trying to find good cube root. So in this case here, what do you think the cube root of negative 125 is? What do you think the fourth root of 16 is? 2. See what I'm saying? By the numbers aren't going to get all that crazy just because they become so large so fast. We don't mess around with it too much. So all this means is the cube root of negative 125. This is the fourth root of 16. That's an even, isn't it? So my answer should be plus minus 2. And a lot of times the plus minus stuff, as you're simplifying things through or working through that, we're not going to see that very often. We're going to see that when we start dealing with equations. Because we'll do equations with all this stuff as well. Nth root equations. And guess what? You work backwards just like you would every other equation. So it works itself out rather nicely. This is something decent to start with. Same thing goes for exponent-wise. When you're dealing with weird fractional exponents, we've done the fractional exponent stuff. We've done our exponent rules. For example, when we had a to the, what is it? What do they write as m over n? Okay. Something to a, I didn't make a slashing fraction. I'm sorry. Hate slashing. So, slashing fractions. The slashing fractions and the mighty ducks out there. All right. What I want you to think of it this way, bless you. What I want you to think of it this way is, what one is the denominator? The n. That means the n is what goes out here, and the m is out here. So think of it this way, is that the numerator is always above everything else. Does that make sense? It's a very simple way of thinking about it. The numerator of the fractional exponent is above everything else, so order of operations tells you to work inside out. Okay? And that's kind of what they're getting at in their example here. They just wrote it as the nth exponent, and then they put the nth power. What they're doing is they're splitting apart the multiplication, because, bless you, they're just working with the multiplying fraction. So I think, and this works the same way if you have a negative exponent, you just flip it. Okay? If it's a negative, you just flip it over, so just put everything to the denominator. Right? So when you look at an example, it's negative. When you look at an example here, you're looking at 9 to the 3 halves. If I'm going to rewrite this out by hand, what's the nth root? 2, so it's square root. So this is basically the square root of 9 cubed. So if you're looking at order of operations, you work with the parentheses stuff first. That's the inside. What's the square root of 9? 3. What's 3 cubed then? Okay. Go to the next one. You've got 32 to the negative 2/5. Yes, sir? You got 32 to the negative 2/5. He's not happy right now, is he? No, it's not happy. It's sad. So if it's not happy, that means let's make him happy. So is it okay that what's the nth root going to be there when I put that to the denominator? 5. Okay. So it's the 5th root of 32 squared. Now, when you start looking at the 5th root of 32, that means it has to be a small number. What do you think it's going to be? 2. It's not going to be 6. 6 to the 5th power is going to be like something in the thousands. So when you start going through it, you get the 5th root of 32, which is 2. What's 2 squared? 4. So your answer is 1/4. Okay. Not too terrible. And then obviously the last one. What's the cube root of negative 8? Negative 2 to the 5th power is? There we go. Did you notice that I just went through all that and I did not use a calculator? And that's the thing, and that's what it's going to wind up being. It really is. You're not going to see, you might see like a 2/16, but that's, that's 4 to the 4th. What's 16 squared? No, that's 256. Never mind. and honestly, it's going to be numbers that will be clean-ish to work with. Oh no, I don't know what to do. I am afraid. So we start looking at this in terms of equations. So when we start looking at it in terms of equations, guess what you have to do when you do that? You do the exact same thing you've always done, which is nice. Okay? We work backwards through solving the equations with the exponents. Obviously, I cannot take the 4th root to start, because that would be bad. Okay? So what do you have to do first to isolate the x? We just did this one.
I know, I did add. Yeah.
Now, here's the thing. If you want to think of a fourth root, think of the fourth root is taking the square root twice. That's all that means. A fourth root is a square root twice. So what's the fourth root of 81? 3. But now, remember, this is an even number, so that means my answer is going to be... There we go. Okay. Now, what could you do to see if you are correct? Always check your answer. What do you have to be careful of when you have negatives that you're raising to exponents? Lots of some things. Parentheses. Make sure whenever you're squaring, whatever exponent you are to an, what do you call it, negative number, always throw it in parentheses. All right, what about here? What do you have to do first? In this case here, I can't do anything until I take the cube root of both sides. Since there's nothing else after the parentheses, there's nothing I can do, so I have to cube root both sides. The cube root of junk cubed is junk. I don't know what the cube root of 10 is, but I'm going to say that it's just the cube root of 10, because that's what we call an exact answer. Yes, sir. What's that? You said, sorry, you said Mr. Murphy, that I was wondering. Yes, ma'am. Great conversation. We should do this more often. Is that what you're getting at? Well, what's the question about the answer? Shh, shh, shh. Hold up, guys. Yeah. You can write it as n through 2, yes. Guys, you don't have to, you could write this as 2 plus 10 to the third power as well. Either one of those is fine. You can write it as an nth root, or you can write it as a fractional exponent. It's fine. I'm not really worried on that one. Unless it states otherwise, and then go from there. Okay. It's more common to write it as the nth root, not the exponent. All right. So I'm bringing back some other stuff that we've kind of maybe done at one point in time in our lives. And when we start these things out, this one you've got x equals the cube, or excuse me, the square root of -1 minus 2x. And I know it says m, but it happens. And For example, here's an example of one that you have to be cautious with. Guys, come on. Now, oh, I don't know if it showed up. It is the square root of 46 minus x. That's all underneath the radical there. I didn't know if it showed up all the way. This is another one where you do have to, in order to get solve for x, you do have to square both sides. So I wanted to show you an example of one where you do actually have to remind yourself that you have to FOIL something. So you get your x squared minus the 8x plus a 16 is 46 minus x. You okay with that? Add the x, subtract the 46, we get x squared minus 7x minus 30. And then what do we get? What is that going to be? 10 and 3? Negative 10 and positive 3? Okay. So x minus 10, x plus 3. So we check it, you have 10 and negative 3. So that means you just got to go back to your answers and check to see if they work. Now, it's kind of nice because you have calculators. Well, even if you have a basic, I mean, a lot of times you'll have. So, let's see here. If I do 10, we have 10 minus 4, which is 6. And then I have 46 minus 10, which is 36. Square root of that is 6. So that one works. If I use the negative 3, I get negative 3 minus 4, which is negative 7. Excuse me. 46 minus a negative. And that one works too, because you get minus a negative 3, you get 49, which is also, you can get plus or minus 7 as well. Okay. So you're looking at, does the answer work versus doesn't it work, that kind of stuff. It's pretty straightforward. Yeah, then you just know. All right. What changes when you have a fractional? Nothing. Okay. And I'll show you a little trick here when we get to the fractional. I think working with the fractional ones is just as simple. Okay. So let's see, we have 491 equals 4 times the quantity, 31x plus 1 to the 5/3 minus 9. Exactly. So the very first thing you're going to do is what? Add the 9. Okay. When you add the 9 over, no. What do you treat it like you would treat that stuff in the parentheses like you would just a variable of x. You want to get that stuff by itself, so you got to move everything else first. Okay. So now what do you do? Divided by 4, what do you get? What is it? 3,125 equals 31x plus 1 to the 5/3. Now, instead of going into an nth root version here, by writing this as the cube root of that to the 5th power, what exponent could I multiply that by to turn that exponent of 5/3 into 1? Yeah, 3/5, the reciprocal. You use the reciprocal property to do that, okay? Because when you think about it, when you had x squared, to undo x squared, what'd you do? You square rooted it, which means you went to the half power, right? You've been doing this all along. You've been using reciprocal properties, but not knowing that that's exactly what you were doing. So what you're going to do you go to the 3/5. So in your calculator, you can probably take a guess of what 3125, the fifth root of 3125 is. What is it, the last number in that? 5. So what do you think it's going to be? 5. Which means, and see what I'm getting at? A lot of these numbers work real clean. So you get, when you type that in the calculator, you can write it as 3125 to the 3/5 as the fractional exponent if you like. Or remember that it's got to be a 5. It hits at a 5. You're taking the 5th root of something. So that's one of two ways. So you get 5th root. So it's 5 cubed. So you get 125, I believe. And you're left with that. So basically what we've done here, ladies and gentlemen, is that we've taken your standard 2-3-step equation to a 4 or 5-step equation just by working with exponents. And you're still working backwards like you have been all along. I believe you get 4 for that. Okay? Reciprocal property.